Hey everyone, the next brand of curves we need to know how to sketch are the trigonometric curves, and we'll start with the sine x curve. Alright, so I'm just going to give you the sketch first because there's not exactly a way to really deduce it or get it. So alright, so something like this, you look more not necessarily symmetrical, but it look like the same on both ends. Alright, but this is the general shape of the sine x graph. Alright, so I'm going to introduce a few terms for you guys, right? So you notice that the curve kind of looks the same, right, from left to right. Alright, and the idea is that there's this thing called the interval, right? Because they have the same shape, they must have the same shape for a particular interval. For this case, one of the intervals is at 0 to 2 pi. Alright, so this end here is 2 pi, right? AKA 360 degrees. Alright, so that means a complete cycle, so this is a interval or cycle, occurs at every 2 pi starting with 0. Alright, so we have y equals sine x, and we're going to look at the graph at one full interval or one full cycle, where we have x is between 0 degrees and 360 degrees, or we have x is greater than or equals to 0 radians and less than or equals to 2 pi radians. Alright, so this is the interval or the domain or the value for one full cycle, one full sine cycle. Alright, which goes up and then down. You can see one hump up, one hump down. Alright, I'm going to give you the particular values you need to know for the sine x graph. Now, this maximum value occurs at y equals to 1, and it occurs at pi over 2. Alright, or 90 degrees. So that will be the maximum value of a sine graph, right? So the value of sine, the maximum value of sine x at any interval, let's say between 0 and 2 pi, will be at 1. Alright, of course, if let's say you have a smaller value, a smaller interval, let's say you have 0 to less than pi over 2, then the maximum value wouldn't be at 1. But now we're considering the full interval, so maximum value will be at 1. The minimum value will be at the negative side, right? The bottom hump. And this will be minus 1. Alright, so this value here, which is also this value here, is minus 1. And it will occur at, well, let's take a look at 0 to 2 pi. It will occur at 3 pi over 2, aka 270 degrees. Alright. So another thing is, if you notice there's also another x-intercept here in the middle. This occurs at 180 degrees. So pi or 180 degrees, and then of course the next interceptions will be at 2 pi and 360, which marks the end of one sinusoidal interval or sine curve. Alright. Now if you look at the left, it's almost the same thing, right? In fact, over here at minus 1 is minus pi over 2. And at the maximum value, you have 1, again, same as the maximum value of sine x, but now at minus 3 pi over 2. So if we continue the cycle, so let's say it does continue eventually, you go up and down again, from here you go up and then down again. It's actually never ending. But you notice that it always keeps the same shape, right? This hook, right? This first hump and then lower hump, right? Now the idea is that you go by the interval, right? So we know that this interval is from 0 to 2 pi. The next interval will be from 2 pi to 4 pi, and then 4 pi to 6 pi. If you go backwards, you'll be minus 2 pi to 0, and then minus 4 pi to minus 2 pi. If the idea that every interval is 2 pi times, the next value will be at 2 pi. As such, when we say that the maximum value of sine x equals to 1 occurs at pi over 2 or at 90 degrees for x, it means that, well, you can actually add 2k pi, because you can add 2 pi k times, so it means k intervals away, or over here it will be plus 360 degrees k times, where again it's k intervals away. Alright, same thing for our negative value, where we have 3 pi over 2 or 270 degrees equals to x. Alright, so we have plus minus 2k pi plus minus 360k degrees. Alright, so that is the shape of a sine x graph with the critical values at 1, minus 1, at pi over 2 and and 3 pi over 2, and 2 pi. Alright, so these are the few values you need to know from a sinusoidal graph, where the maximum of sine x is 1, minimum sine x is -1.